Good morning everyone. Welcome to this video lecture series of wireless cellular and 4G LTE module number 1, lecture number 4. So today we will be dealing with how the channel independent multi-user rescheduling is done in LTE system, and along with that a very important topic, that is multiple antenna techniques. Okay, what is the necessity of using the multiple antenna, what are the various advantages of multiple antenna? Okay, so which we'll be dealing with in this particular video lecture series. Okay, so let us start with how actually this channel dependent multi-user rescheduling is being done. Okay, so basically what we know in LTE system, that there is something modulation which is called as OFDM modulation scheme. Okay, and this is one type of a special modulation where this LTE which provides more flexibility, okay, in channel resources allocation. Okay, what do you mean by channel allocation or the resource allocation? Okay, if you speak generally, we call it as the resource allocation. Okay, now what type of resources? That is channel. Okay, how you are trying to allocate the resources in LTE system, that is what we will see now. When you go for allocation of the resources, they will be categorized into two. That is, one is in whether you are doing in the time domain or whether you are doing in the frequency domain. Okay, and for that, either it is in time domain or in the frequency domain, you need to design an algorithm such that the resources should be allocated properly and in such a way that they should be flexible and it should be dynamic. Okay, dynamic is in the sense, whenever the user want to access to the resources, it has to allocate the resource. It should not wait for some amount of time. It means that there should not be any delay kind of activity should be carried out in that particular allocation time slot. Okay, and therefore the other requirements like arbitrary throughput is nothing but whatever you feed it has to get it. Okay, then delay and some other kind of requirements are there in the channel allocation. Okay, so that is how the standards are supported in LTE system. Okay, so therefore by making use of this OFDM technology, the resources allocated in this particular LTE systems are far more better than they are compared with CDMA, TDMA and FDMA. Okay, and apart from the channel allocation, okay, your LTE systems will be, or the user, okay, user is nothing but the mobile user or the subscribers. Okay, they will be experiencing a lot of uncorrelated fading channels. Okay, and it is only possible to allocate to the sub carriers among users in such a way that the overall capacity is increased. Okay, if you want to increase the capacity of your the channel, okay, then you need to make sure that all the sub carriers, I've given an example yesterday that if the number is 100 and if you are dividing it into 10, 10 and 10, that is total 10. So for each 10, that is nothing but the subscriber, you have to allocate the resources. Okay, then only the capacity can be increased at a large. And this type of technique where you allocate the possibility of the resources for each subscriber is called as frequency selective multi-user scheduling. Okay, and for this, the focus should be completely on the transmission power in each user's best channel portion. Okay, and if you try to do this, that is proper transmission power for each user, then the overall again the capacity can be increased. Okay, so the another thing here is in the frequency selective scheduling. Okay, so good channel tracking is also possible, or it requires the good channel tracking. You need to have a track for each sub carriers. Okay, and there are also some slow carriers are there and there are some fast carriers. Okay, slow is nothing but because of some object which is coming in between, and if they get faded or when they get strike up, okay, so there will be kind of a reflection and refractions and other things are happening. So therefore it should be taken into the consideration, and then you need to have a proper track of that particular frequency. And in OFDMA, the frequency selective scheduling, it can be combined with multi-user time domain scheduling. Okay, which calls for scheduling users during the crisis of their individual fading channels. Then if you want to have the gain capacity, or if you want to capacity gain, can also be adapting the modulation and the coding to the instantaneous signal to noise ratio condition for each user subscriber. Okay, so this is how the channel independent multi-user rescheduling is done. Okay, or scheduling is done. The only thing here is what we need to have the focus here is how you are trying to allocate the resources and how you are trying to increase the capacity of the channel. Now, coming to the next topic is multiple antenna or multi-antenna techniques. Okay, if you have one antenna, more than one antenna, we call it as multiple antenna, or we can also call it as an array of antenna. Okay, so LTE standards provides an extensive support for implementing advanced multi-antenna solutions. Why it has to provide the solutions is nothing but just to improve its link robustness. Okay, that is what, if you have one antenna, it requires more amount of time, then transmission power will be more, everything get increased. Okay, but if you have a parallel antennas or array of antenna or more than one antenna, okay, both at the transmitter side or at the receiver side, okay, then you can improve the robustness. Then you can also increase the system capacity, because handling capacity will be more, right? If I have one antenna, it requires some amount of time. If I have two antenna, then it can be divided, three antenna again divided, so the division of time can also be possible. And apart from that, the spectral efficiency is can also be improved. Okay, so based on these three parameters, that robustness, system capacity, and the spectral efficiency, the deployment scenario for this multiple antenna techniques, or the techniques which are supported for the LTE, particular LTE systems, are: first is the time diversity. Okay, what do you mean by time diversity? Is nothing but it's a type of a technique, okay, which we use in the antenna, that to combat the multipath fading. And I have said about the fading, that if you are transmitting some signal and that particular signal is going to hit some objects, some buildings and some trees, okay, then it causes fading. Okay, so if it travels to multipath instead of traveling it to a single path, we cannot say that all the signals will travel to only one path. It will travel to multipaths. All right, so therefore when this technique is adopted, that the multipath fading in the wireless channel, then the time diversity exists. Okay, and what is the idea behind this particular time diversity is nothing but it send multiple copies of the same signal, right? So instead of sending one signal, I will send multiple copies, one copy, two copy, three copy, four copy, but I cannot guarantee that all the copies will be received at the receiver. That is what, because some copies may get faded, some copies may get discarded due to signal to noise ratio, addition of the noise, external noise, right? So therefore, instead of sending one copy, you send multiple copies of the same signal, but all the copies should be coded differently. Coded differently is nothing but, for example, if I'm sending signal 1, I will give as a code as A. If I send signal 2, same signal, I will give it as B. Third signal of same signal, C. Same signal, D, right? The codes are different, but the signals are same. That is what the difference is. Okay, over multiple antenna transmitter, multiple transmit antennas, right? So if I have 10 antennas, it means that I have 10 different codes, but all the 10 different codes have the same signal. This is the idea behind the time diversity, right? But in LTE, the time diversity is based on space frequency block coding, or we also call it as SFBC technique. Okay, and it's a complicated with the frequency shift diversity, that is SFTD, right? So when four antennas are used, okay, so now it is limited to four antennas. Okay, if it can also be reduced to two, or it can be more beyond four also. All right, so transmit diversity, it is primarily intended for the downlink channels. Okay, and always please remember, whenever you are speaking about the wireless communication or any wireless signal, okay, there will be always uplink and downlink. You can call it as other name as download and upload. Okay, upload belongs to uplink, downloads belong to downlink, right? And always the downlink frequencies are more as compared to uplink, because we are the users, right? We always try to download the signals, download the information rather than transmit the information, right? So if you just click at one link, but that link behind that, there is a huge amount of data which will be entering into our mobile phones, right? So therefore, in the transmitted diversity, the more focus will be on the downlink channels rather than the uplink channels. So therefore, it is not always possible to make use of channel dependent scheduling, right? Because I cannot completely depend on the channel scheduling, because at any point of time the signal may get downloaded and you need to have the proper resources at immediately. So therefore, in time diversity, they are completely cannot be used. And the second thing is, and it can also be applied for user transmission such as low data rate. Okay, then VoIP, when you go for the IP protocols or IP addresses, where the additional overhead of channel dependent scheduling may not be justified. So therefore, the time diversity increases the system capacity and the cell range. So if you are trying to make use of an LTE system, then the time diversity is must and should with along with the multiple antennas. Therefore, it increases the cell range. What do you mean by the cell range is actually the cell will be appearing to be as a hexagonal cell, right? So automatically your cell range is expanded, cell range is increased. It means that if the cell range increases, it means that the capacity is also increasing. Then the second type of advantage or the technique used in the multiple antenna is beamforming. This is another important topic in multiple antenna, that it may be used to transmit the same signal appropriately weighted for each antenna. In the sense, all the weights will be assigned in appropriate manner, right? So therefore, such type of effect, it will be more focused in the transmitted beam in the direction of the receiver. For example, if you have a one receiver, one transmitter and the one receiver, or multiple antennas, multiple transmitter and multiple receiver, right? So therefore, what we try to do is we try to assign the weights in the sense giving some numbers or giving some codes, right? Usually this happens in the machine learning or in the artificial intelligence. You need to assign the weight, you need to assign the thresholds appropriately, right? So why we need to do this is nothing but just to focus our beam into the direction of receiver, right? So therefore, we try to make use of beamforming technology or beamforming method. And what happens if you do this is you can improve the signal, received signal to interferences ratio, because a lot of interferences will be happening into the wireless channel. So this can be improved by making use of beamforming technique. And beamforming can also provide significant improvement in coverage range, because in wireless communication, coverage is the more important. If there is no network coverage area, then it becomes very big problem. So therefore, nowadays you can see we hardly face the coverage range, right? Maximum time some or the other, the strength of the signal is different, the coverage is different, right? You go anywhere, you will get the signal, right? But the signal can be weak, or but the signal can be strong enough. Okay, then you can have the improvement in the capacity, you can increase the huge capacity or of the number of users. Then the reliability is nothing but easily it can be acceptable, easily it can be workable. And the battery life. Okay, so this is another important point, and it can also be useful in providing angular information for tracking, because nowadays we also go for the location tracking, right? So for the location tracking, we require the angular information, that is called as the latitude and the longitude of that particular link. So therefore, we try to make use of GPS systems, right? Or the location. So therefore, if you try to make use of this particular beamforming technique, this LTE will cooperate in a better manner. Okay, then the next type of the technique used in the multiple antenna is the spatial multiplexing. Okay, we know what is the definition of multiplexing, that is transmitting the multiple signals through a single channel. Okay, now what do you mean by the spatial? Okay, so the actual idea behind the spatial multiplexing is that the multiple independent streams can be transmitted parallelly. You need to send all in the parallel over multiple antennas, and they can be separated at the receiver by receiving chain through an appropriate signal processing. Now we will make use of some signal processing kind of mechanism at the receiver, that all the signals, when they are received in a chain one after the another, or whether they are in the parallel, okay, they will be appropriately segregated by making use of some signal processing techniques. Okay, and this can be done as long as the multipath channels, multiple channels can be seen by different antennas are decorrelated. That is nothing but at the receiving side, as it could be a scattering environment. Okay, but theoretically, the spatial multiplexing provides the data rate and capacity gain proportional to the number of antenna. It means that if the number of antennas are more, then there is a possibility that you may have some very good data rate, you may have some good kind of a capacity, but they are completely proportional. Completely proportional is nothing but the number of antennas will be proportional to the better gain. More the antennas, better the gain, better the capacity, better the higher the data rate, right? And it works well under the good signal to noise ratio. Even though if we have some better good signal to noise ratio and some light load conditions at the receiver side, then we can go for spatial multiplexing technique. And this spatial multiple techniques or multiplexing is used in LTE system. Now, whatever the things I'm trying to say here is they cannot be incorporated in your 1G, 2G, and 3G. or 3.5G. They all are included in 4G technology, right? So therefore, the LTE standards support the spatial multiplexing with total up to 4 transmit antennas and 4 receiving antennas. Now, the last type of advantage here is the multi-user system or MIMO systems. Okay, this is another important thing. In the last video lecture, also I have just covered what is actually MIMO systems. But since we are trying to make use of the spatial multiplexing, we require multiple inputs and multiple outputs. Okay, MIMO system, it is called as multiple antenna. Okay, so here in the MIMO system, the multiple antenna transmit chains, it is currently not supported in the uplink. Okay, but due to its complexity, okay, and cost consideration. But however, the MIMO systems which allows multiple user in the uplink with each single antenna. It means that I can have one antenna at the transmitter, but I can have multiple antenna at the receiver side. So this also comes under the MU-MIMO systems. Okay, to transmit the same frequency, but they are all are separated at the base station receiver. All are separated at base station in the at the tower side. They all be separated with their accurate channel state of information, because channel information is also included when the signals are being transmitted. Once the signal gets transformed from once the signal get out from your transmitter, your channel information also be transmitted, because channel information is more required for the receiver, because without channel information the signal cannot be reached properly or cannot be decoded properly at the receiver side. Okay, this is the only thing which is required here in the MIMO system. But some kind of uplink reference signals can are also been added, but they are orthogonal between the number of users, or you can say, or different users. Okay, so this is how the channel dependent multi-user resource scheduling is done in LTE system, and as well as the multiple antenna techniques are done in this particular uh, LTE system. Okay, so with this I will be stopping this particular lecture today here itself. Okay, thank you.